Yeah.
Those all of them that you really get.
Right.
You want, if you give me page green, I can do hers.
She didn't come that day. Okay. All right, so let's finish number 5. We were at a place, I think, it was almost at the end, right?
You were also, we didn't understand what
We
you
were
were
at
doing.
angle BAC minus angle MAC.
Would you like the
Right, and
test?
we didn't actually have to do that. So is this A, this is B, this is C?
No.
Totally wrong.
You want to see the test?
A,
Or the,
no, A is at the top. B
And
is
then
at
it's
the bottom.
X and X.
That one's yeah.
Yeah. After doing it for a couple more times yesterday, it went well.
you did it for your other class?
Of course, right? By that time. We started to hit the nail on the head right here. We started to figure it out.
Yeah.
So I labeled this, I think, as pi over 6 minus theta,
Mm-hmm.
or theta, yeah. Right? Right. Okay. So what we have here is a right triangle, and this whole side is 2x.
Mhm.
Everybody agree? And what's pi over 3 equivalent to in degrees?
That's 60 degrees?
60 degrees. So it's a little easier to think about when it's in the degree mode. If that's 60, then this whole thing up here is what?
30.
It is indeed 30.
Which in radians is pi over 6.
Right.
And then so that other angle is going to be pi over 6 minus theta, and we're left with angle MAC.
Right. Okay. Now, if I know this is a 30, 60 right triangle, I know there's special numbers that go along the sides. It's a 1, 2, square root of 3.
Yeah.
Does that make sense? So this, across from 30, is times 1.
Yes.
Hypotenuse would be times 2.
Yes.
So if this is 2x, then this is 4x, okay? And then it over here is 1 times the square root of 3. So this is 2 square root of 3x. Does that make sense? Yes.
You just multiply 2x times square root of 3.
Right. Okay, so are we good? So we have a 1, 2 square root of 3 triangle. Everybody okay with that so far? Okay, so it wanted me to show, the problem was something. It wanted you to show that theta equals pi over 6 minus the tan to the negative 1 of 1 over 2 square root of 3.
Mm-hmm.
Right. So, it wants you to actually solve for this guy theta here,
Mhm.
right?
Yes.
So does it make sense if we find the whole angle, we end up finding that, you guys told me that yesterday, that BAC minus MAC is going to give us that, what we're looking for. Does that make sense? So what is the whole thing? What is the BAC equivalent to?
30.
Also known as pi over 6.
Pi over
right?
6.
So BAC is pi over 6.
Yes.
Is that cool? So we actually have to find the angle MAC. Alrighty? If we go through this process, we can actually find sides and angles of these opposite sides. So for example, this guy here, if I'm looking for whatever this is, it is the opposite, right, over adjacent.
So x over 2 times the square root of 3x. So, which the x's cancel. So that's how I get the 1 over 2 square root of 3.
Right. So if I'm looking at this from this angle here, from this whole angle, this is opposite, this is adjacent, right?
Mm-hmm.
Okay, and you guys told me it was BAC minus MAC. So MAC is going to be, if I kind of look at it this way, bless you, okay? So it's the tangent, right, of pi over 6 minus theta. So far, so good.
Yes.
And then opposite over equals opposite over adjacent.
Mm-hmm.
Everybody cool with that? So far, so good?
Mm-hmm.
So what happens with the x's?
They cancel.
Become a 1. That goes away. Now, we try to make it look like this a bit, right? So what do I do to both sides? Inverse tangent. So pi over 6 minus theta is equal to tan to the negative 1 of 1 over 2 square root of 3. So far, so good?
Subtracting and multiplying.
So we have theta is equal to tan to the negative 1 of 1 over 2 square roots of 3 minus pi over 6. Actually, negative theta, right?
Plus,
Which, if I negate it all, it becomes this thing right here.
well, and then doesn't one of your pi over 6s cancel, or because you got 2 pi's over 6s, right?
Well,
Yeah.
what do you think?
I didn't see the two
So theta is equal to pi over 6 minus tan of 1 over 2 squared 3.
And what about the other pi over 6?
I don't know whether we actually have to do a BAC minus that, because we just found we solved for theta. We didn't have to utilize that at all.
But that was only 2 points.
I know that was a hard one for 2 points. I would consider it a difficult one.
So if we saw one like that, you would consider skipping and come back to
Coming
it?
back to it.
Yeah.
You could do that. I mean, I wouldn't not come back to it altogether. Just don't like click in there, you know?
But do what you can do first.
Right.
Oh,
Okay, is there another on there?
you see, number 11, part II was a little confusing. It wanted you to use the discriminant, but it doesn't really seem like they weren't really leading you up to that. Like, how would you have known to do that?
Oh, okay, gotcha. That's the same case as the last one we did, where I said it was a little difficult. So this is f of x is equal to 6x minus x squared minus 5, right?
Mhm.
And it's an x is an element of the reals. So first of all, before I do anything, what is this a visual of?
It's a parabola that faces down, and its y-intercept is -5.
Okay, so we all know that, right?
Mm-hmm.
We're cool with that now? So we know it's opening down because there's a negative in front of x squared.
Mhm.
So you have a visual, right? Okay, find a set of values for which f of x is less than or equal to 3. Well, anytime I see less than or equal to, I should think what?
A chart.
I should think a chart. Exactly right. So I know this is an inequality. I know I'm going to have to create a chart. Okay, so we have 6x minus x squared minus 5 is less than or equal to 3. Do you agree? It just wants me to take
Yeah.
the function and make it less than or equal to 3. So if I bring it all to one side, alrighty, I have negative x squared. So far, so good.
Or you could add it over the others.
Which I will. Mhm. I'm just going to kind of show my work. I'm going to subtract that out. So minus 8 is less than or equal to 0. Yeah.
I have a question. So if you're dividing or multiplying by a negative, the inequality sign flips?
So you could do that right now. You could say negate, 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 flip. Does that make sense?
So then it would be positive x squared minus 6x plus 8 is greater than or equal to 0.
Correct. That would make life easier for factoring purposes, I think.
Mm-hmm.
Okay, so if I go through the process of factoring this, I know I've got x minus 2, x minus 4, right? So my special numbers are 2 and 4.
So it's when x is less than or equal to 2.
Okay, so x is less than or equal to 2.
And then 2 is less than or equal to x, which is less than or equal to 4.
Good.
Mhm.
And then 4 is less than or equal to x.
Perfect.
Yeah.
Now, people question, why are we doing less than or equal to when this says greater than? It doesn't matter. Remember, it always goes in that same direction.
You're just finding intervals that it'll fall into.
So
Right.
you would do like 1, 3, 5.
1, 3, 5. And where do I plug it in?
You plug it into where we factored it.
Right here.
And you want it, if it's greater than or equal to 0, then that means it's a yes. If it's less than, then no, it's not what we want.
Right, exactly.
Right.
So if I plug in a 1, I got a negative. If I plug in a 1, I got a negative.
Which
2 negatives make a positive.
we want it.
So it's bigger than 0, so it's a yes.
And then
no and
usually
yes.
it means yes.
So we think no, yes, right?
Yes.
Let's make sure.
3 minus 2.
So if I click 3, I get 3
1.
minus that would be a positive and a negative, so it's a no.
So no.
And then we're just going to put yes, but we're going to make sure. That's a 5, yeah, that's a 3 and a 1, yes.
Yes.
So the answer to this, the intervals, is x is less than 2 union 4 is less than or equal to x. Everybody good with that? Remember that? Yes.
I looked on the mark scheme. They don't set up tables like that.
They don't have that. It's my old lady trick to make it easier for you.
It makes everything more organized.
I think so. It gives you the opportunity to, yeah. to me, it's clearly showing that you understand it's a continuum of numbers, and you're kind of assessing them in each of those continuums.
How much was it worth?
It was 3 points.
That was 3 points?
That was 3 points. So, yeah, that was 2, that was 3. So crazy, right?
I
Yeah.
like it like that.
Yeah,
Okay.
me too.
Can you also create a table to determine whether a function is increasing or decreasing? If it asks,
You would do the same thing. You would take the derivative, you would set it to 0, you would find your special points, which are called stationary points.
so x equals something, x equals something.
Right, and you would go to the left, between, and to the right of your stationary points.
And if it's positive, that means it's increasing, and negative is decreasing.
When you plug into the first derivative, when it becomes positive, it's increasing. When it becomes negative, it's decreasing.
And you plug it into the where you factored it, you multiply the two together, then if that's a positive or a negative.
Right. Another way to do that is if I took the first derivative, I set it to 0, and I found, let's say, 3 and 5 are my two answers.
Yeah.
Then if I took a second derivative, what does the second derivative do for me? It tells me whether it's a max or a min.
Determines the nature.
Right, determines the nature. So if I came out with this being a max and this being a min, right?
Mhm.
What would that tell me about the things to the left and to the right of the number 3? If it's a maximum, what has to happen for that to go? I have to go increase,
Then
to
decrease.
right?
Mhm.
So I would know when x is less than 3, I have increasing.
And when it's greater than 3, it's going to be going down the hill, right?
When, shoot, the other way around. When x is greater than 3, well, no, I was right. I was right. When x is less than 3, I would have gone like up the hill to get to it. And then when x is bigger than 3, probably to place I get this, it would be decreasing. And then it would hit the 5, right? So it's almost like the continuum that I did there. So like from here to here would be decreasing, and then it would start to increase again, so like so. So you kind of see the resemblance of that chart. This is what we call a sign chart. So I took that thought process of a sign chart and created that for you guys to have that same concept. Yes?
And we don't have to worry about point of inflection.
No.
Is that ACE math too?
I don't even know if it's this one too. Maybe a little bit. Okay, so the part II, are we good with this one though? With a little review. Whenever I see an inequality, I would create the chart. It would help. Okay, so for part II, so the function is given by, once again, f of x equals 6x minus x squared minus 5. It says, given that the line y equals mx plus c is tangent,
Which means it's the derivative of that function.
it means that they share the slope at that one point.
So it's a tangent line of that.
Thank you.
It's tangent to the curve, y equals f of x, which is this curve right here.
Uh-huh.
Show that 4c equals m squared minus 12m plus 16. Okay, so what does it want me to do?
Find the derivative.
So if I found the derivative of this, right,
Mm-hmm.
I would know that the derivative of this should be equivalent to
Y is equal
the same place as this, right? The same, like they touch at that one point where that derivative happens. Does that make sense? So what do? I take mx plus c equals what?
Negative 2x plus 6.
Okay. So now what do?
You're going to combine like terms and
the values.
use the discriminant.
So if I bring it all to one side, right? I've got mx plus 2x and then plus c minus 6 is 0.
Mm-hmm.
So if I was to find the discriminant of this thing, I would have b squared minus 4ac. And because they hit once, it's going to be equivalent to 0.
Because it's a tangent line.
Because it's a tangent line. So what's A, what's B, what's C?
A is M and 2.
M plus 2? We don't have an A.
We don't.
Because the A is squared.
Oh, yeah.
0.
It's 0.
So 0.
And then M plus 2.
And so B is M plus 2.
And then C.
C minus 6.
All right.
And then we're just going to be left with,
That doesn't seem right, though.
B squared.
So you took the equation they gave you and set it equal to the derivative at the very beginning?
Yeah, so what is it saying to me? It's saying, let's read it again. It says, given that the line y equals mx plus c is tangent to the curve, so basically I have this parabola that's opening upside down, right?
Mhm.
And it's telling me that this line, mx plus c, is tangent to the, real close to it, is tangent to the curve. That's pretty. So it's tangent to the curve, just like that. It wants me to show that 4c is equal to m squared minus 12m plus 16. So what do I have to do to show that these two are working? So I have to actually say the original function, right, is going to be equivalent, the actual function is going to be equivalent, so if I took its derivative, someplace on its derivative is going to be equivalent to basically the mx plus c, because that's what they hit.
so if they intersect, that means, you have to set them equal to each other.
In the original format, right? Isn't that what we did last time on that problem?
I think it was
We did
either,
one a couple days ago.
Yeah, I'm looking at that one, but we didn't take the derivative.
We left it equal to the original.
and we did something with the
And
discriminant.
then we did something with the discriminant.
And we got two values for m, right?
Right, so we're gonna take mx plus c and set it equal to 6x minus x squared minus
This is one of
5.
the ones where it's already derived, they just don't say it, right?
No, it's that, this is the slope. So, they're telling me that this
This
is the tangent.
So it's like.
Meaning the
okay.
derivative would have been done, that would have been done, the equation would have been found.
Because the
Yes.
derivative.
Oh, I think I understand, because the actual equation, which is 6x minus x squared minus 5, meets the tangent line because it hits it at one point.
Right.
So that's why we
the
set,
problem is, we don't actually have to find the derivative, we actually got the derivative.
because
without being-
those two equations meet each other.
There we go. Now we're on a roll.
Mhm.
So now, same process we did a minute ago, because we meet once, right?
Yes.
So let's bring it all to one side. So we have x squared, that feels a little better.
Mhm.
And then we have plus mx minus 6x plus c plus 5
Plus 5.
equals 0. Check my work.
Yes.
So I took that over there, I have these two guys together, I have the c and I added the 5. Are we good?
Mm-hmm.
So A, this feels a little better, A is 1.
Mm-hmm.
What's B?
M minus 6.
6.
And minus 6 and
plus
C.
5.
So you just factored out the x's.
C plus 5.
It's kind of weird because don't get caught up in that.
It's only C.
It's only C.
It's not actually C.
Right.
It's just
We're
that.
going to call it C.
It's a constant.
Right. I hate that. Okay, so say that again.
You just kind of factored out the x's to get all of them.
Yeah. So you say whatever's in front of x squared is my A, whatever's in front of x is my B, and whatever doesn't have an x are my C's.
Okay.
So in this case, B squared minus 4 times A times C. That feels a little better. Okay, are we good? All right, so let's go through this process. Here comes the rain, right? So we have m squared,
Glad, so those fires will stop.
I hope so, minus
There's a
12m
fireman.
plus 36, right?
Uh-huh.
And then negative 4 times C, so
Negative
minus
4.
4C.
Minus 20.
Okay, it's really equals to 0, because they touch 1.
Yes.
Okay. What? No? What? You sure? Okay. So we have m squared. It wants me to make it look like that.
Yeah.
Yeah.
So basically, what does it want me to do? It wants me to bring 4c on one side and leave everything else on the other.
Mm-hmm.
Are
So
we
could
okay?
you just like knowing that's what your answer and you have all the numbers, can
Yeah.
you just like rewrite?
Yeah. Make it pretty and you're done. So you'd have m squared minus 12m, 36 minus 20 is plus 16, equals 4c. Do I have what I'm looking for? Yes. And that's where you go.
Wait, that's a minus? Okay, Never mind.
You
I
good?
just both look like equal signs.
Right. Yes.
How many are you supposed to use B squared on 4AC?
Okay, that's why I said last time that if I had to pick, I thought the most difficult problem on the test, I would have picked this one because it does not insinuate that you have to use b squared minus 4ac is 0. But you understand that a tangent meets the curve just once. So that's when you know, because it meets just once, I know that I have b squared minus 4ac equals 0.
Oh, that's right.
That's why I mean it's hard. It's not difficult work-wise. It's just the concept. You have to pull those two things together.
It is down.
We'll take it. A lot of times what they'll do is they'll say, show they meet once, show they never meet, show they meet more than once. If that's the case, you're going this route where you have less than or equal to's, right? So those are typically, they'll lead you down the path to knowing you have to use that discriminant. This one doesn't really insinuate discriminant. You just gotta assume, yes.
So wouldn't it be a case where we would use the chart, but we had b squared minus 4ac is less than 0 or
Okay,
greater than
so
0?
if it says show that, show the intervals where they never meet,
Mhm.
b squared minus 4ac is less than 0. Take your two things equal to each other, bring it all to one side, do that.
How did you know not to do the b squared minus 4ac for this?
Well, because it's only once, so it's equal 0. Therefore, you don't have a chart.
I meant for that part.
Well, that
Well,
Hold
it's a
on.
totally different type of problem. That was definitely, it said less than or equal to 3.
But if it says they never meet once, or meet twice,
Right.
then that tells you the discriminant.
Right. How about if it says show that it doesn't have any x-intercepts, no roots,
Then that means it's imaginary roots, which means it would be less than 0.
right? Because it would be a picture that kind of looks like this.
Like a parabola that never hits the x-axis.
Right. Okay, so there's a whole lot of different ways they can ask you to use a discriminant. This one, they're making you use a discriminant without really saying use a discriminant. That's why I feel like it's one of the more tricky questions, because you have to figure out what is exactly they want me to do with it. Yes.
And the discriminant tells you how many times it touches.
Touches the axis, the x-axis, or each other.
Okay.
So if you have one equation, how many times it touched the x-axis?
They went to the river.
What were they? What? They went to
They went to the river at this period.
That's. Miss K, so what are they asking like on this one? Because like you read out, so like what are they? Is
This
it
guy
just
here,
giving the
they
equation
just
or-
said f of x show. You gotta read it. Is that in here?
I think you have
I
it.
stole it.
That's kind of.
I do that.
That's hilarious.
Find the set of values with an S for which f of x is less than or equal to 3.
Okay. That's all it says.
That's it.
They're not telling you, do they show that they meet once, show that they meet twice?
Right. They don't tell you that. They don't tell you that. Hello? Hi. That's up to you. They're studying for their test for tomorrow. Okay, bye. Okay. It's a smile. Okay, the function g is given by, so let's go to the next one. Are we good?
Yeah.
I really like this problem because it really kind of brings a lot together, kind of gets us to.
Is this like for III?
This actually has, that was 6 points total so far we've done, and then it has 5 more points to do.
Holy
So wait,
crap,
right.
that's a big-
So it's actually a 5-part question. Okay, so let's go ahead to the next one and see. It says the function g of x is given by 6x minus x squared minus 5 for x is greater than or equal to k.
Mhm.
It says express this in the terms in this format. So what does it want me to do?
Complete the square.
They're going to tell me, complete the square. We know that's what it is. Remember, there are 2 different types of complete the square, one of which could have a number in here or out here. Pay attention to that, okay? So if the number was in here, and let's pretend you had a 4 out here, you would bring a 2 in here. You would take the square root of the number out here and bring it in and multiply it through.
Yeah, it was like an odd number, like say it was square root of 7, would you just put the square
Square
root
root
of
of
7
7 through.
Or would you put like the decimal?
You would put square root of 7 in, but they won't do that.
Okay.
They'll put a 9 or 16 outside.
An easy one.
Yeah, yeah. Okay, so the first thing we're going to do with this, I'm going to rewrite it in the order it's supposed to be in. Set it equal to 0, just as a review. Next step is I'm going to add the 5 over here.
Mhm.
Are we good so far? Do I have anything in front of x squared?
Yes.
Yes, I do. I need to take care of that, so I'm gonna factor it out. Okay, notice that I took care of it after I brought the 5 over.
Yeah.
So factoring out that negative does not affect that 5 at all. Okay, now that I have the outside, I'm gonna take b, I'm gonna divide it by 2, and I'm gonna square it. So negative 3 squared is 9. I'm adding 9.
But are we really adding 9?
We're not.
No,
What are we adding?
Negative.
To the other side.
That's right. Are we good? Does that sound familiar? Okay. On the left-hand side, we have what we call our perfect square. It's negative x minus 3 squared. And this right here is negative 4, but if I bring it back over, it's positive 4. And where do they want me to have it? Out front.
Just make sure your order's the way they want
What
it.
they want, right. Okay, are we good so far? That's it. That's the answer.
I have to remember, so when you're doing the b, it's just before you square it, right?
The b,
The b is before you square it, right?
before I square it.
It's b over 2 in parentheses squared.
There.
So it's just b.
Yeah. Now, state the smallest value of k for which this has an inverse. State the smallest value of k for which this has an inverse. Well, what is this, guys? It's a parabola.
Hmm.
It opens down, right?
Yeah.
It opens down.
Goes to
What is its vertex?
3.
It's negative, or 3, 4.
So, positive 3, 1, 2, 3, up 4, 1, 2, 3, 4, and it opens down.
Mhm.
Okay. It wants me to find the value of k for which x is greater than or equal to that k, which allows me to have an inverse. For something to have an inverse, it must be 1 to 1.
Monotonic.
Monotonic, meaning only going in one direction. In this case, it's going up, then down. So what is the smallest value of k which allows me to have an inverse? It's the place at which the x is a line of symmetry.
You do typically to the right, right? You want to
Well,
keep
in
it.
this case, x is bigger than or equal to k. So I care about the things that are bigger than that. So this is what I'm keeping.
Yes.
So I'm gonna get rid of all this stuff right here. Well, where's the place I stop?
3.
At 3, I know because it's the x value for the vertex, so k. So this question was, state the smallest value of k for which this has an inverse. It was a 1-pointer.
Question. And how do you know it was k?
Um,
I mean, not k, how do you know it was 3?
it's the x value of the vertex.
Okay. I don't know the vertex question. Because that's like a negative outside of parentheses, does that matter, or?
That just means it's opening down.
What was it asking us? Okay, the smallest one.
State the smallest value of k. Why the heck do we care if it's the smallest value? Well, because what if I picked 4? If I picked 4, it's still 1 to 1. If I picked 5, it's still 1 to 1. So I could pick anything from here forward. So I could pick an infinite number of answers, but they're telling me I want the smallest one. So I want the place at which smallest possible value. 2 would not work because it would start to go up, then down. So 2 would not work. So the smallest place it works is when x is 3. Yes?
So couldn't it be, if it was k, it's less than or equal to 3, like if you're restricting the stuff?
Pick the largest value.
Right, that would be like if you get rid of the right and you care about the left.
Right?
Mhm.
Very much. Then the next thing says, for this value of k, find the expression for the inverse. I am now allowed to find the inverse because it is 1 to 1.
Mhm.
So literally, I'm going to use what I just found to find its inverse. Don't try to do an inverse from here.
We got to solve
Gotta do
easier.
it from here, right. So right now, I have 4. Okay, I have 4 minus x minus 3 squared, and that is equal to y,
Mhm.
right? So that's step 1. What's step 2?
Flip the x and y.
Flip your x and y. So x equals 4 minus y minus 3 squared. So
Mhm.
far, so good. Next step.
Solve for y.
Solve for y. So bring the 4 over. X minus 4 equals negative y minus 3 squared
Divide that negative out.
by the negative out, which means I could flip this to be 4 minus x equals y minus 3 squared. So I negated it and just flip-flopped it, yes?
Take the square root of both sides.
And when I take the square root of both sides, I get two answers. I get plus and minus, so we're gonna have to pay attention, right? So one of them, I'm not gonna use. Okay? I'm concerned about the right-hand side.
So it's just positive.
I'm concerned about the positive stuff.
Now, could you bring the 4 out and just have like the square root of negative x?
Yeah, so would you
No.
leave it as like the square root?
You've
of
gotta
x
leave the
x?
square root. That 4 cannot come out because it's attached to negative x.
Okay.
That would be a big no-no. And so finally, the last thing here, two last pop. I have 4 minus x, I'm gonna add 3. I put the 3 up front so I don't make the mistake of making it look like it's under the square root. And name it what it is, g inverse of x.
So whenever it asks for the inverse, we do the
I would label it.
switch the y and then.
Yeah.
That's just
Interchange x and y, solve for y, and then call it what it is. And that was worth 2 points. That 2 points is a whole lot easier than the triangle 2 points. Meg?
So if I would have squared the 4 and then brought it on the outside, I would have gotten like 1 point.
You would have, yeah, maybe, because that would be a no-no.
Dang it.
Yeah, so don't
Do you know
overclean.
mark scheme is?
Yeah.
That's your.
Sure. I had a question.
Yeah.
So I think there was one question like on a test where it said it gives you f of x and it gives you f of g of x and it wants you to find g of x. Because we typically do it the other way around where we, so like how would that come about?
We did one as a practice in here as well. Where was that located?
I think that was in the
On
our
one of
take-home
your-
test.
From one of your take-home tests.
Have you graded those?
I've started grading them. I actually graded chapter 7 tests, they're in, they're over there ready to return back. And then I started grading these take-home tests. They're gonna take a little while.
Well,
Unfortunately.
I think I need to give yours back because
You do, after you're done studying, you do that.
I didn't even get a point. You literally just get 2 points for the answer.
You just got 2 points for the answer?
Yeah. You wouldn't even get 1.
You had a question?
Yeah. Do we take That's A it. lunch tomorrow since we did that?
What time does the test start?
12:15.
I would have to think, yeah, right?
So the BD is one.
Huh? I think it would be a lunch. If it's, because it's Wednesday. Yeah, go to a lunch, go to Bird's lunch. All right, let me see if I can find that.
see, on Wednesday we get out at 2:15, right?
Yeah.
It's an hour and 45-minute test.
Okay, here it is. Let's see, this is number 8 from the take-home test version 1.3. So it says, part I says, express 4x squared plus 12x plus 10 in the form of ax plus b squared plus c. Hi!
How are you?
Good, how are you? I was just asking about you yesterday. Yep, I asked your mama how you doing. How's everything?
It's all right.
Yeah?
Yeah, I'm working, school.
What'd you bring?
First.
Actually,
Okay, bring the 10 over.
It will set it to 0, right?
Uh-huh.
Yeah.
Not the machine or whatever.
Like that.
Or is it okay?
We're completely
Yeah.
square.
Oh,
4 first. So
Yeah.
pull out the 4.
Even if it doesn't go in evenly.
Uh-huh.
Like if it was 4x squared plus 7x, you'd have to have a fraction.
Uh-huh. Which would be a buggeroo.
I got the exact reason.
Okay. Now, what do I do next? Come on, move. So I'm gonna take b divided by 2. I'm gonna square it. So I get 9/4, right?
Yes.
I'm adding 9/4 here, but am I really adding 9/4?
You're adding 36/4, which is 9.
9, so plus 9. Good. So then I have 4 times x plus, take the square root of that. It's this thing before it's squared. So 3/2 squared,
It-
okay?
yeah.
And this is what? That's -1, so plus 1. Are we good so far?
And it's always like if you have a fraction, it's always going to be the b over 2. That's always going to be that.
Yes.
They want you to put the 4 back.
They want you to put the a back in. So you're not putting a 4 back in. You're taking the square root of that number and putting it in. Because eventually it'll be squared, so you take square root so it can get squared. So instead of a 4 going in, you're putting a 2 in. So what you get is 2x plus, what's 2 times this?
Wait, why are you saying this?
It wants you to have the a inside.
No, but you
You take the square root of it, because if you were to undo what you did, you would be squaring, and so you want it to go back to where the 4 was.
Okay.
So if I multiply the 2 through, I have 2x and then 3, which is really nice. Squared plus 1. Yes.
What happens to the 2? Or it goes away? Because the 4 just comes at 2 that gets multiplied with the x and the 3
You get
halves.
6 halves.
Yeah.
Okay, so the 4 comes in as a 2, because it's the square root. So you do 2 times x, you get 2x, and then what's 2 times 3 halves? Well, it's 6 halves, which is 3.
Oh, you're,
Distributing it, yeah. Okay, so that was the first part.
Wait, what was the question?
It says, express that in terms of that. Okay, so that was 3 points. The next one says, functions f and g are both defined for x is bigger than 0. It is given that f of x equals x squared plus 1. And f of g of x equals 4x squared plus 12x plus 10. And then it says find g of x. Okay? So do you agree for f of g of x to happen, I actually have to take something, stick it into this to make it become this, right?
Yes.
I gotta take a g and stick it in here. So take what we just got for an answer, okay? And how similar is this answer to the actual f of x? It is something squared plus 1, right? Do you agree? What would I have stuck in there to make it f of g of x? So in other words, what is a g thing that I stuck in there? Well, it's this stuff right here. So g of x is 2x plus 3.
Oh.
So I took, okay, so what I gotta do is, this was the original. F of x was the original, x squared plus 1, right?
Uh-huh.
So tell me, how is this different than this? The only thing that's different is, instead of it being an x, it's 2x plus 3 squared plus 1, right?
Which is 4x squared plus 12x plus 10.
Yeah, so when I stick this in here and clean it all up, I get that. So the idea you recognize is, what did I insert? Well, I inserted this, okay? How do I know that? Because that's how it changes. So I just call that the g of x. Yes?
Or can't you just like divide g of x divided by x squared plus 1?
No, it's not a division problem. You didn't multiply to get it in. You actually plugged it in. You didn't divide, you didn't multiply it in.
You combined
You
it.
don't multiply those two things to get this. You actually insert one into the other. You compose it, okay? But you would have to get it in this format to be able to recognize what changed from there to x squared
Or
plus 1.
the answer, you don't have to show work, you just literally say
G of x equals, right, it's a
zero.
1 point question.
Well, they made it kind of easy for you to just see. Oh yeah, that makes sense.
Very
Yeah.
easy, now that you know it's a 1 point question, they try to make it light. And then the last thing says, find the inverse of f of g of x. So the only way you can find the inverse of this is if it looks like this.
Because we can solve easier.
So you can solve easier. So you're gonna make this equal to y, you're gonna interchange the x and the y, and then you're going to
Solve for y.
solve for y in terms of x, and you'd have your inverse. Just remember, you can't find an inverse when it looks like that, but you can find an inverse when it looks like that.
Because don't you have like multiple y's and you can't get it alone because there's
Right.
too much
Right,
going
you
on?
can't distribute, you can't factor the y out by base. You can't factor the y out.
Yeah.
Are we good? Sweet. Okay, I don't know, I think I've done everything I can. I don't know. What do you think? Yes?
when we're, copying down our unit circle, should we put it on the test or on the reference sheet?
Well, there's my question. This unit circle it's a problem. It's the way they give you the test now, it's not on paper. Let me talk to Ms. Matthews and see if we can bring in a sheet of paper so you all can just instantly write it down on a piece of paper and we throw it away on the way out, maybe? I don't know.
And when do we start writing it? Just like if they're still handing out the tests? Just
You can't
Start
write
writing.
out the test until you get,
You know what?
start.
But it's not the
I know.
test that you're doing though. You're just doing something just for.
Just to say it's helping you for the test.
You guys have the test, right?
Which one?
What do you-
These are all copies of real tests. So, let's see. I didn't copy the last page. The last page usually is like a blank page for work. So what I would do is, what I would probably do is when I go to take the test, I would open it after they say you can open it and just jot that down quickly. That's what I would do. Yeah.
Couldn't you do this test without writing down the unit circle? Because I mean, that does take time away from.
It's up to you.
If you have it memorized, then yeah, but.
I really feel like it's better. Let me see that. I feel like it's better for you to have the ability to do that.
Because some of the questions you might not need to use the unit circle for.
You don't think so? I don't know.
Is it in the library?
Yeah. Here. Like this is an example of a past one. Here's the back, blank page. Wouldn't that be a perfect spot for it?
Yeah,
I would think so.
we can write on those.
Yeah, these tests are fine to write on.
And then it
Now,
gives extra
understand
space.
that this is not what's getting turned in at the end of the day, so if you do your work on here, you're out of luck.
Okay.
Oh, it's just-
Yeah, we're gonna give you a place to do your work. This will just be for your unit circle purpose. Yeah.
But the blank page is on the back side, so technically you don't have to open the booklet to get to that page. So if you just turn it over and just.
I don't know if I push the envelope. You're gonna have plenty of time. I believe you're gonna have plenty of time. I believe they've set up this test, so, there's plenty of time. Sometimes people are done working on it, and I'm like, I think you should still be working, because.
Maybe because they didn't know what to do, so they just
Possibly. So it kind of breaks my heart.
they just guessed and said, whatever.
Yeah. So, all right. Anyhow, I gotta make a phone call real quick to Miss Chanel.